So this is the problem when you have a cavitation, right? Okay, I told you that in the center of the impeller, the pressure is very low. That's why you get the water is sucked from the well to your pump, right? So which means you know that the pressure in this impeller, in the middle of the impeller, is very low, right? There is a condition where the pressure in this impeller is below the vapor pressure. If it is below the vapor pressure, the water will start to boil. Yes, cavitate or evaporate, whatsoever you call it. It become a gas. Right. It become a gas only in the middle, only in the center, the eye of the impeller. Now, the pump working like when you have this is a very low pressure, but at the tip, this is the leading edge, the trailing edge, at the trailing edge, the pressure is very high. That's why it can push the water, right? So in the center, it has a very low pressure that it can suck the water. At the outside, the side, it has a high pressure. That's why it can push the water. Now you can imagine when it has a cavitation form in the center of the pump, when this bubble moves to the trailing edge, the pressure is getting higher, right? Yeah. So what will happen?
Collapse.
It will collapse. It will pop, break, burst. Whatsoever you call it, right? It seems harmless. It seems harmless if it is only one or two. But if you have a million of it and it happens all the time, you get those so-called. Okay? This is the end result when you have a cavitation. Your blade will be corroded and eroded. Okay, we call it a pitting corrosion. And one of you thinking to have FYP on corrosion, this is the so-called pitting erosion. Pitting corrosion. Right? So this is what happened, and it's very bad. We do not want to have it. That's why the pump manufacturer decide to have the so-called this net suction pressure head, net positive suction head. Okay, this is the required. Okay, this is the required. So you need to have more than this. If it is less than this, the cavitation will occur. Okay, so this is what happened. If you have your NPSH is more than the required, no cavitation will be occur. If you have less than that, cavitation will occur. So how do we calculate the NPSH? Is the difference between the pressure available at the inlet, right? The pressure available at the pump inlet with the vapor pressure head. See, this one is the pressure available at the pump inlet. This is the vapor pressure. Okay, simply like this. Okay, you are son of Hercules. You bring a very big bucket. You cannot. We cannot. We are normal human. We cannot bring this. So it's very big. Why I need very big? Because if it is not big, the V1 will not be zero, right? So I do not want that. So I want, this is very big. So either you are son of Superman, or you are the Superman itself, or you are son of Hercules. Okay, now guys, this one, you are not talking about the outlet. You are talking about here. This location. When you have something like this, you can be sure that the pressure here will be positive, right? Because this one is going there. So you will know that this one will always be more than the atmospheric pressure, right? At least, because here you have atmospheric pressure, And then you have the Z. You like it or not? You just see the velocity there. Then you will have always positive pressure. Right? Positive pressure. So cavitation will not occur. Now Hercules is tired. You do not want to hold it anymore. You put it there. Now what will happen? You do not know. You do not know whether the cavitation occur or not. But you need to calculate it here. What is the pressure in here? In this location. Okay, so you need to calculate this. Right? If the value of this is bigger than your required NPSH, no cavitation will occur, you can use the pump. If this one is lower than the required NPSH, cavitation will occur, you cannot use the pump. Okay? Because not only it destroys your pump will not work. Your pump is not designed to pump gas. Right? Pump is designed to deliver liquid, not gas. If you have a gas, you need to use a gas pump or compressor. Okay? That's why if you want to be rich, if you can design the so-called multi-phase pump. Multi-phase pump is very, very important in oil and gas industry because when you drill the oil there, you will not luckily get only oil. You know that? You will get gas, you will get oil, you will get water, you will get sand. No rock, because we put perforator there. Okay? When you crack it, you put perforator. Perforator is like filter, right? But it's made of metal, of course. So the thing that you can get it is only sand. Okay, now the problem is, if you put compressor, compressor cannot compress the liquid. Liquid is incompressible. Okay? If you put pump, pump cannot deliver the gas. So you need the so-called a multi-phase pump. And multi-phase pump is very expensive. Very expensive. Okay? When I take the course of introduction to the oil and gas industry in Singapore, in NUS, the one who teach me is the one who has one patent on multi-phase pump. And the reality is crazy. Like you do not need to work actually. You don't have to work at all. You just sleep at home, that's it, enough. You will get, every month money will come from BP. Because he designed those pumps, those multi-phase pumps. Okay, so if you want to be happily ever after, right, having a good horse, right, you patent something, then you will be rich. Yeah, you can sleep forever. I can help to dig the hole also. You want to sleep forever, right? So, be careful with your wish. Huh?
Is the multi-phase pump like only available for oil and gas?
No. It's available for all, but it's very expensive.
Other fields such as?
Pharmaceutical, they use it. But mostly, yeah, it's oil and gas. They are the one who can afford to have it. Okay, so this is how you can calculate it. Okay, and one more thing. How do you calculate that one? This is by having a Navier stone. The Bernoulli equation between point here, your point 1, and here, the inlet. Or you can call it depends. If the equation is only this, the equation is only this, you can call it point 2, right? But if somehow I have another point there, it depends on how you give the point number, right? If you put this one 1, 2, 3, then it's between point 1 and point 2. Okay, so you calculate the pressure, okay, and the velocity. Then you can calculate the NPSH. Okay, let me show you one example how to do it. Okay, okay.